The empirical formula for ethane, C2H6, is best written as what? So we're looking for the empirical formula for ethane, and that is our molecular formula for that particular chemical compound. So again, let's go ahead and scratch out a row to our solution. Step number 1, define the mass of the individual elements identified through the analysis of the sample. Use the periodic table to define the atomic weight for each element. Define the number of moles for each element present in the sample. Divide the mole value by the lowest of all the mole values. Round or multiply all moles by the smallest multiple to obtain a whole number. And then lastly, write out that empirical formula. So let's go ahead and start with step number 1. Again, we don't have an analysis in this particular problem statement. We are giving the actual chemical compound with the associated molecular formula already, which means we can go ahead and skip over steps 1 and 2 and go to step number 3 in defining the number of moles for each element present in the sample. So once again, we will use a table just to organize our work. We have our molecular formula. We know there's a carbon atom, a hydrogen atom. We know there are 2 to 6 hydrogen atoms, so the ratio is 2 to 6. We can now move to step number 4, where we divide each mole value by the lowest of all the mole values. So here our lowest mole value is for the carbon, that's 2. So we divide each by 2, so 2 divided by 2 is 1. 6 divided by 2 is 3. So now we can either round our results or multiply that result and all the moles by the smallest multiple to obtain a whole value. In this case, once again, we have whole numbers. We can move on to 6, where we write out the empirical formula. We focus on that empirical moles column, and we can write our empirical formula for ethane as CH3. So the correct answer, the empirical formula for ethane, is B, CH3.